All right, so today we're doing section 9.3, probability. So a probability of an event, it's always between 0 and 1. And indicates the likelihood that an event will occur. The theoretical probability, we're going to call it P of A, is equal to the number of outcomes in event A over the total number of outcomes. So the theoretical probability is the number of outcomes in event A over the total numbers of outcomes altogether. So here's an example. We all know in the card, it's on the board, in the deck of cards, we have 52 cards total. So what is the probability? Find the probability of selecting a jack. How many jacks are in a standard deck of card? 4. So the probability of selecting a jack is 4 over 52. 4 out of 52, that's the total. And if we simplify, this becomes 1 over 13. What is the probability of selecting a red king? Remember, half of the cards are red, half of them are black. So we have 2 red kings and 2 black kings. There are 4 together. So 2 red kings. So it will be 2 out of 52. And that simplifies to 1 over 26. And then C, what's the probability of selecting a not a queen? We know that there's 4 queens in a standard deck of card. So that will be 52 minus 4 queens, so that will be 48 over 52. Those are not a queen, equal to 12 over 13. On permutation or combination, the Cobras now show variety. It allows students to showcase their talents every fall. For the Friday show, they have 10 acts, so that will be the total, scheduled to perform. The order in which the acts perform is randomly selected during the show. So now let's read A. What is the probability that the acts perform in order of their age? So now, since we have the word order, and there's 10 of them, 10 different acts, 10 different people performing, in order of their age, I need first to do a permutation. So because we talk about order, so to find the total, that will be 10 out of 10, 10p10. So 10 math probability 10. 10 math probability 10. So the total will be 3,628,800. So then, what is the probability that the X, all 10, perform in order of their age? That will be what? 1 out of 3,628,800. So those are all the total outcomes. I can have one student who's born in January, one of them February, and then flip them around.
How do you get to probability?
2 of your friends are singers in different X and you're part of the 10X. What is the probability the first 2 performers are your friends? Is this important, the order? No. So we're doing 2 out of 10. So first we have to find a total. So 2 out of 10 to figure out the outcomes. So 10 math probability 2 So then we have 45 different outcomes. And what is the probability that the first two are your friends? So the probability that the first two going are my friends, it's again 1 out of 45. Order is not important again. It's just picking two friends out of the 10. To the next one. So you have an equally likely chance to choose an integer between 1 and 30. Find the probability of the following. A factor of 16 is chosen. So let's see. So we know for sure that in the denominator the total is 30. Out of 1 through 30, we have total of 30. What's the probability of a factor of 16? So let's count the factors of 16, the numbers that we can divide 16 by. I can divide by 1, by 2, by 4, by 8, and 16. So there's 5 factors of 16. So what is the probability that we chose a factor of 16? 5 out of 30, or 1 over 6. Okay, we're choosing again a number 1 out of 30. What is the probability a perfect cube is chosen? So let's see. 1 cube is 1. 2 cube is 8. 3 to the third power is 27. If I do 4 to the third power, that's 64. So that's not included on my list from 1 to 30. So there's 3 perfect cubes out of 30 numbers. So that will be 1 out of 10 we're picking. That's our probability. That's our chances of picking one perfect cube. Okay, so now this was theoretical probability when we know for sure what's the outcome in the numerator of event A over the total. The experimental probability of an event consists of numbers of trials. So the probability of A is the number of trials where A occurs over the total number of trials. So that's the experimental, when the trials happen. So find the experimental probability of an event. Johnny spins the spinner 60 times. His results are below. We're missing here color purple, the way they print it. So if he spins it 60 times, so that's a trial. It's an experimental probability. It lands on black 17, it lands on blue 15, on orange 21, purple 60. What is the experimental probability of a spin of orange? So I'm doing first the experimental one. It lands on orange how many times? 21 over 30. Can we simplify this by 3? So that would be 7 out of, no, 60, sorry. Out of 60. 21 out of 60, that's the total. So that if we divide by 3, that will be 7 over 20. So now let's just do the, in theory. That's the experimental one, based on this chart. That's a trial. In theory, if I have 4 different colors, what are my chances to getting an orange? 25%, do you agree? 1 out of 4. There's 4 colors. In theory, I should get 25%. So that would be in theory, because 4 colors, that would be 1 out of 4. That's the difference between theory. 4 colors, 1 out of 4. 5 colors, if we're picking one color, 1 out of 5. But the experimental, based on this, it's 21 out of 60, which is 7 over 20, which is about 35%, 0.35 here. And here is actually 0.25. Which color has an experimental probability that match its theoretical probability? What's 25% of 60? 15. So this one will be, so the experimental will be 15 out of 60. which is 1/4, which is 25%, is the same as theoretical one. In theory, to pick any color is 1 out of 4 will be blue, 25%. So those two match. Do you see the difference between them two? Yes? This is a trial. We expected to have 15, 15, 15, 15 because there are 4 colors. 25% of each. But by doing the experiment 60 times, that's the experiment, they didn't land 15, 15, 15, 15. They land different ways, like 21, 15, 21, and 7. All right. This page here is missing. Again, printed. This is supposed to be like this. Pretend it's a square. So the small circle radius is 2, the medium one is 4, and then the biggest circle, the radius, what do you think it is? 6 inches. So 2 radius for the small circle, 4 for the medium one, 6 for the big one. And then if the radius is 6 and it goes all the way to the top of the square, 6 plus 6 is 12, so diameter here is 12. Since the radius is 6, diameter is 12. Okay. Darts are thrown of a square dartboard. The inner circle is worth 10 points, so this is where it's worth 10 points. The middle worth 5 here, if you land here. And a larger one is 0, 2 points, and in the corners is 0. What is the probability that the darts land in the bull's eye for 10 points? So what's the probability of getting a 10, meaning landing here? What do you think we have to find? Area of what? Of that small circle. Area of the circle, if you recall, is pi r squared. So in the numerator, we're going to have the area of the small circle divided by, what do you think I'm going to divide by? It's a probability. What's the probability of getting in here? Divided by the entire board, the square, the entire board. So this is for 10 points. So find the area is pi 2 square divided by the area entire board is the square, so it's 12 square, 12 times 12. So that will be 0.0873. That is the probability if you put it into your calculator. Or if you want a percentage, it lands 8.73% on the 10 points bullseye. What is the probability that the dart lands outside of the circle for 0 points, meaning here? How do we find that area? So the probability of getting 0. We have to find the area of the corners. Then we have to do the square minus the big circle to get the area of the square, the outside. So that will be the area of the entire board minus the area of the big circle. But then again, don't forget to divide by the area of the entire board. So this is the probability of outcome A, the corners, divided by the total board. So the entire board here will be, the square is 12 square minus the area of the big circle. The big circle, the radius is 6, so pi 6 square. Everything divided by 12 square. So now if you put this in a calculator, that's about 0.2146, which is about 21.6%. So as you work, check your answer with mine. I did, even though they're asking theoretical ones, I did the experimental one to, what's the experimental probability of getting a purple, 7 out of 60. I did both of them, just you guys to see the difference. Okay, one more time for, let's call this C. To an example, find the probability of getting 5 points where I color blue. So to find the area of the blue region here, you find the area of the medium circle that has the radius 4 minus the area of the small circle with the radius 2, and then we have to divide by the entire area to find the probability. Okay, and then one more thing that we're gonna learn today is odds and favors and odds against. So, when you do a probability, you always have the denominator is your total number. With favor and against, odds in favor or odds against, if they ask you what's the odds and favors of me, let's pretend we have 30 students in class, 14 girls, 16 boys. What's the odds in favor of me picking a girl? 14 girls, and against is 16 boys, so it will be 14 out of, yeah, so we're gonna have favor in the numerator over against in the denominator. So let's pretend if I have 30 students, and that 14 are girls and 16 are boys, what's the odds in favor of me picking a girl? That will be 14 to 16. So we will not have 30 in a denominator. So the odds in favor of picking a girl will be 14 girls to 16 boys. So now what will be the odds against? That will be against in the numerator over favor in the denominator. So what are the odds against picking a girl? Against picking a girl will be what? 16. That's against. And favor will be 14 girls. That's the difference between odds in favor, odds against, comparing to having the total in the denominator. And of course you can simplify that. So let's see, Miss Davies assigns homework studying and no homework out of the 30 days. So homework is 20 days, studying is 6, and no homework 4. Find the odds in favor of assigning no homework. So that will be no homework favor. So how many days she assigns no homework? 4 is no homework, and what's against the homework? Everything else. No homework is 4. Everything else is against no homework. So that will be 30 minus 4 is 26. So this will be favor, and this will be against homework. Everything against. So that's 2 over 13. Find the odds against assigning homework. So I need against in the numerator. Against over favor. So against assigning homework. How many days she assigns homework? 20, but I need against homework. So that will be 10. If 20 days she assigns homework, then against that it's 10. 30 minus 20 is 10, so that's 1 over 2. And the last one, find the odds in favor of Miss Davies assigning studying. So I have favor over against studying. So in favor of studying is 6. Everything else is against studying, that's 24. So 1 over 4.